Hello viewers, it's Abdurrahim Babatunde Bukola, your host today on this showcase video on how to model a reverse osmosis plant with Aspen Plus, Aspen Custom Modeler. How to simulate the process. I created a model I created this model based on this research paper, optimization of design and operation of seawater reverse osmosis plant. To follow the equation and the likes, I wrote a Aspen Custom Modeler code which I used to create a model that has this formula for the reverse osmosis plants. You have the reverse recovery rate. You can see the description for the variables here. Osmotic pressure, permeability parameters are given in the result. So you have the parameters set up. So you can see the permeability. You can give the value. I think these values are calculated. Okay, I think I fix the recovery the pressure difference and this retentive pressure. That's why I fixed something. That's why you have all these values being calculated. This is the permeate pressure and the numbers of cell, numbers of pressure vessel, number of pressure elements is given to calculate. So these are the major parameters that you need for a reverse osmosis plant. So I think I have already fixed this recovery rate, you can see, and the salt rejection rate. So it will give me the specification that I need for the membrane. You understand? For the membrane that I'm trying to work with. So you have this molar permeability is given, so and the likes. So if you go to this setup, it will give me the permeability specification for each of the components. I'm trying to separate water and sodium chloride. You understand? So the salt rejection rate is the rate at which the salt is being removed from the feed water, and you can see the profile from here. So this is the profile of the salt rejection rate, or the flux of water and the flux of salt. So you can see that of salt is lower from the onset, you understand, and the rate is also different. So then you can see the second one, the second profile, which is for the flow and the composition of the salts in each of the range. So this is the flow of water, or total flow of the permeate section. This is the total flow of the reference section, and there you can see the readily move fraction. Then the pressure too, the osmotic pressure that is calculated for each of the sides is given over here, and the average molar concentration of salts in the system is also given from the code. And you have these results. This is the profile that you can use to make decision on how to design the plant. So, and in order to buttress more on it, I designed the plant for the RO system using this code. So this is the inflow. So you can see multiple train of reverse osmosis and the high pressure pumping station that is given in order to optimize the process, and you can see the retentate rate produced for the process by integrating it to Aspen Plus. You can see the composition of the brine that is produced. Then for the salt, for the pure purified water, the desalination water, this is the permeate section. It's coming from the permeate section. You can see the composition of water is 0.9999, which is the product specification that is given, and this is like 89 ppm, which is less than 100 ppm. So that's the specification that was given, and we are able to get it using the reverse osmosis plant. So that is the recovery. The total flow in is 730, and the amount of water that is recovered is very important, is is 649. You can see 649, so it's not far from it. So, and you have the pure water that is basically the forward. You can see the power of all those pumps. So very important to keep track of them to know the specific power utilization of the plant. This is 40 kilowatts. So for the low pressure, let me check the typical power. 28 kilowatts. Why is the other one 40? No, why this one is having negative power. So 11 kilowatts. Okay. The pressure is definitely high already, so it's like a valve or something. 83. Okay, because it's coming from the retentive, I'm supposed to put like a valve there. Okay, supposed to be a valve. They don't need a pump here. So my bad. Um, so that's the introduction of the project. So thank you for staying tuned. See you on the next one.